Hey everybody, today we're going to talk about linear functions and specifically the characteristics that we can point out on a graph. So a couple of vocabulary words that we want to remind everybody about is domain and range. And we've talked about how your domain are your x values in a relation or all the different x values in your ordered pair. So specifically, we can say that your domain are the set of all x values in the function. And again, we're talking about linear functions, so root word line in linear functions. So we're looking at graphs of lines. And then your range values are your y values that are corresponding to the domain or x values in an ordered pair. So your range would be the set of all y values in the function. So you can see in our example here, we have a line that seems to be going all the way up and all the way down, but something that we have to also identify is how far to the right and how far to the left the line is going. So for your domain, remember, we're talking about the x values in your function. Okay, so let's remind ourselves about that. So then we have to think about two different things. How far to the left are we going? And how far to the right are we going? And when I say go to the left, will you actually go to the left, and can you go to the graph at some point if you go down or go up? So if I go to the left, yeah, I can go down. I'm going to hit the line at some point because the arrowhead indicates that we are going forever to the left. So how far does the line go? Well, we can say that the line is going all the way to negative infinity on the x-axis because we're going there. We're slanting. The graph is slanting left all the way forever. And how far does the line go to the right? Well, we can see that the graph is going up, but it's also slanting to the right as well. So if I go to like possibly 12, notice if I go up past the actual picture screen, at some point I'm going to hit that line because the line's going to go off and go forever to the right. So we can say the graph is going all the way to positive infinity. So when we're answering the question, what is your domain of this function? Well, we ask ourselves how far the line goes to the left, how far to the right it goes. Then our answer would be negative infinity to positive infinity. Now, similarly, we want to look at the range, but remember the ranges are your y values that correspond with the x values. So we want to ask ourselves how far up the line goes. So if we look at the line, we notice that it's going up forever. So that means that we're going all the way to positive infinity. And then how far does the line go down? Well, we can also say that it's going down to negative infinity. So your range of this function, your linear function, would be from negative infinity to infinity. Now, if you look at these three other characteristics or components that are important to linear functions, we need to know and identify what our x-intercept is. So our x-intercept is where the line will actually hit the x-axis. Okay, so here's your x-axis, here's your y-axis. So specifically, we know that our point's going to be right there. That's our x-intercept. So when we identify our x-intercept, we write the coordinate 2, 0. That is our x-intercept. That's where the line crosses the x-axis. So now we're looking at the y-intercept. Well, that's where the line's going to cross the y-axis. So here's your y-axis. Where does the line cross the y-axis? Boom, right there. We'll put a dot there. Let's highlight that. And then write down the coordinate where the line actually crosses the y-axis. Okay? And then finally, we have the slope or the rate of change. Remember, we talk about slope being the definition of the rise over the run. So you got our rise first, and we rose about 5. I picked a random point just out of curiosity. I picked this point specifically because it's landing on one of the corners of the boxes. So then I rose, and I want to rise to this point here. So I rose 5, 1, 2, 3, 4, 5. And then I'm going to run to that point, and I'm going to run 2. So then my rise and run is 5 over 2. So my slope is going to be 5 over 2.